All right, 4-5, we're still talking about congruent triangles, and we're going to talk about 3 more shortcuts today. We've already learned that SSS is a shortcut and SAS is another shortcut. Today we're going to talk about 3 more shortcuts, and those are ASA, AAS, and HL. The first one we're going to talk about is ASA. Again, we're trying to prove 2 triangles are congruent. And in order to know ASA, we have to know the vocab word included side. It's very similar to an included angle, except now it's an included side. So an included side is a side that is included. And when I say included, that means it wants to feel included. So it's in between 2 sets of congruent angles. So for example, if I told you that this angle, and if I wanted to talk about this angle and this angle, I know something about those 2 angles. The side that's in between those 2 angles is this one. So this is the included side. Okay? So for ASA, the side angle that we can use as a shortcut to prove triangles are congruent, this side, it has to be touching those 2 angles that we know about. And so if you look in this picture, we know angle A is congruent to angle D. We know angle C is congruent to angle F. Those are our 2 congruent angles, 2 sets of congruent angles. And then that side that's touching, that's in between, it's included between those 2 sides, 2 angles, excuse me, is AC and DF. So if I only know about 1 side length and 2 angles that are touching those sides, then the triangles will always be congruent. Now, something you want to look out for, remember, is our vertical angles. So let's say, for example, I give you this bow tie, and I tell you that this angle is congruent to this angle over here, and that this side is congruent to this side. There is still enough information, even though I didn't finish, because these vertical angles are congruent to each other. And again, if we wanted to read it, I'd go from 1 tick mark to 2 tick marks. So I would start here. That's my angle. Okay, so sorry, I read from 1 tick mark to 2 tick marks. So I would start with this angle, this 1 tick mark on the angle, and then I'd go to the side. It's touching the side, and then it's touching another angle. So I know that that's ASA because the side is in between those 2 angles. And this one, same thing. I have an angle, I have a side, and I have an angle. So since they're both ASA, the triangles are congruent. That's the one shortcut. Again, make sure you look out for vertical angles. Something else, another shortcut. Let's see. Actually, let's look at number 3 and number 4 before we move on. Something you're also going to want. Remember always to look out for the reflexive POC when 2 triangles share a side. So for number 3, it says, can you use ASA to prove the triangles are congruent? I have 2 angles, and let's see. The side that's an implied or a tick mark that they forgot to tell you about was this middle one. So if you look at it, it says, can you use ASA to prove the triangles are congruent? Well, if I read from 1 tick mark to 2 tick marks, I have angle, and then I have a blank. I can't do that. So what if I reverse it and I go from 2 tick marks to 1 tick mark? I have angle, angle, and then for here I'd have this side. So again, now I'm going like this, because I can't skip blank things. So AAS is what this triangle is saying, and that's not ASA. So I would put no. That side is not touching both of those congruent angles, or those sets of congruent angles, rather. Let's look at number 4. Number 4, same thing. Can you use ASA to prove the triangles are congruent? Well, okay, I know that this is going to be congruent to itself by the reflexive POC. Remember, we're going to be using the reflexive POC a lot. And we also have parallel lines. Whenever we see parallel lines, I want you to immediately think alternate interior angles. And remember, alternate interior angles is like the Z. So they look like this. Okay, so once you see parallel lines, and again, those have to be touching the parallel lines. These angles are touching the parallel lines. So since these ones are parallel, that means that this angle is going to be congruent to this angle. And that's really all we know. We have 1 set of angle and 1 set of sides. So no, these are not congruent triangles. We can't prove it by ASA. Okay, so that's the first one. Again, I I don't like how the book doesn't give you enough examples, and I apologize, but we'll work on it in class. The second shortcut is AAS. AAS, the side this time is not touching both of the angles, it's only touching one angle. So in your own words, this is it does not have to be included. It's non-included. It's excluded, if you will. Feels left out. Okay, so if you look in this picture, we have one set of congruent angles, this first A. So we have G is congruent to K. We have a second set of congruent angles. We have J is congruent to M. That's this one. And then we have a side, one set of congruent sides. We have H, J, and LM that are congruent. And this congruent sides only touches one of the angles. If that happens, these triangles are going to be congruent to each other. Another picture, a better example to give you is something like this. I think we just did one. So let's say we have something. I'm going to tell you that these two angles are congruent, and I'm going to tell you that these are parallel. And are these triangles congruent by AAS? Well, let's see. We have this side that's congruent to itself by the reflexive puck. We have parallel lines, so we know that these alternate interior angles have to be congruent to each other. So now if you read it, we have an angle, and we have a side. This side is not touching both sets of angles. So this is AAS. This is an example of AAS. And if you read the other triangle, same thing. We have an angle, and we have a side. Remember, parallel lines does not mean that they're congruent. So do not mistake these parallel lines for congruent lines. They're parallel, but they're not necessarily congruent. Okay? And we'll talk about that more in class because a lot of people forget that. And then the very last shortcut is called HL. So far we've been talking about A's and S's, and all of a sudden they throw this HL at us. What are they talking about? In order to talk about, HL stands for a hypotenuse leg. And when we talk about hypotenuse, we're talking specifically about a right triangle. At the first part of your page talks about hypotenuse. That's going to be the longest side. I believe we've already talked about this before. That's the longest side of a right triangle. So we're going to only use, so this one, here's a right triangle. This one is the hypotenuse. It's always across from the 90 degrees, and it's always the longest side. When we have right triangles, it has its own triangle congruence theorem, and that's called HL. So again, this is only for right triangles. We have to know that the hypotenuse is congruent to the other hypotenuse, like in this picture, AC and DF are congruent to each other, and they're hypoteni, because they're across from the right angles. And we need to know that a leg is congruent. A leg is not a hypotenuse, so you need to know one other side is congruent. So if you have a right triangle, two sides need to be congruent. In a right triangle, two sides need to be congruent. And the triangles are congruent. And we'll talk more about how you can use Pythagorean's theorem, a squared plus b squared equals c squared, to prove this. And we'll talk about why it's called HL rather than using our S's and A's, because if you used A's and S's, you might spell a bad word. So that's why they use HL instead. All right, so really quickly, I'm going to do number 5, and then you guys are going to try number 6 and 7, and we'll be done. Don't forget to do your reflection. Number 5, are these triangles congruent? If so, why? Well, let's see. We know that this is a right angle, so this one's a right angle as well, and we know that this side is congruent to itself by the reflexive property of congruence. So we have a hypotenuse, and we have a leg, so these are congruent by HL. All right, so you're going to try 6 and 7 in the reflection, and we are done. Fun fact of the video. Did you know you can beat brain freeze by sticking your tongue to the roof of your mouth?